Okay, today we're going to talk about the trig modeling example number 2 from section 9.5 in our online textbook. This example, if we read it together, and we'll point out the important pieces of information as we go along before we start answering questions. So we have a weight attached to the end of a long spring, and it's bouncing up and down. As it bounces, its distance from the floor varies sinusoidally with time. You start a stopwatch. When the stopwatch reads 0.3 seconds, the weight first reaches a high point, 60 centimeters above the floor. Pretty important information, so we're going to underline that. The next low point, 40 centimeters above the floor, occurs at 1.8 seconds. Again, some good information that we want to know. Now the first thing it asks us to do is to sketch 2 complete cycles of this sinusoidal function. We want to label everything we can from this information. So what I would do is just start off, let's just sketch ourselves a graph. And let's get all the information on this graph that we know for sure. And all we know is really what we just underlined in our paragraph. So we know that at 0.3 seconds, my weight reached a high point of 60 centimeters. We also know the next low point. I'm just going to plot that high point first. The next low point was 1.8 seconds. And that was 40 centimeters above the ground. Now, with these 2 points, what we just plotted was half of a cycle, half of a cosine cycle, really. We went from high to low, and we did half of a cycle. To complete our cycle, we're going to need a few different things. First of all, let's do the thing that's a little more obvious. And if my high is 60 and my low is 40, the center of my graph is going to be at 50. So I know my center is right there at 50, and we'll label that with a dotted line. Now, if we look at the distance between our high and our low point on our x-axis, you notice that from 0.3 to 1.8, that distance is about 1.5 seconds. So if half of a cycle is 1.5 seconds, my complete cycle is going to be 3 seconds. If half is 1.5, my complete cycle will be 3 seconds. So if I start at 0.3, I'm going to complete a cycle at 3.3, which is 1.5 seconds from that 1.8 that we have on the graph already. So now I've completed a cycle, but what I'm missing are where are the seconds where it hits that center. And we always want to do the most accurate graph we can, so we got to figure out what are the seconds where I hit my center. Now, if you remember from when we first started graphing, to find our best scale, we always take the period and cut it in quarters. Now, the period is how long it takes to complete one cycle. So if one cycle is 3 seconds long, which we just figured out, right? One cycle from here to here is 3 seconds. So my period is 3 seconds. So if period is 3, my best scale is going to be 3 over 4, or 0.75 seconds. So my best scale is 0.75 seconds, so the distance between each unit needs to be 0.75. So to fill in those missing spaces, 0.75 from 0.3 is going to give me a 1.05. 0.75 from 1.8 gives me a 2.55. And I'm going to continue, because it said up here, make sure to do 2 complete cycles. So if I just add in these center points here, I've completed 1 cycle. If I continue with my scale of 0.75, we can make another cycle. So I'm going to continue with that. Next would be 4.05, followed by 4.8, 5.55, and ending with a 6.3. Plotting those points, I'm going to be back at the center, down at my low point, center, and complete it with a high. So we have just completed step 1, or part A rather, completed 2 cycles of the sinusoidal function. Now the next step is to write an equation expressing the distance from the floor in terms of the number of seconds the stopwatch reads. Now we did all the hard work in part A, figuring out what my center is, my scale, my period, all that stuff. So now we just have to put it into an equation form. And if we remember, my equation, general equation form, I'm just going to move this page up a bit, I'm going to use a cosine function since that's what we've been talking about here. So if I'm looking at part B, so there's part A, part B now is to write an equation. Remember our general equation has A cosine B x minus c plus d. I've got my amplitude, the number of cycles from 0 to 2 pi, my phase shift, and my vertical shift. Now in my function, in my graph we just graphed above, the amplitude, remember, is the distance from the center. So if my center is 50 and I go up to 60 or down to 40, my amplitude is going to be a 10. So right now I know I have y equals 10 cosine. Now b we're going to leave blank for a second. That one we're going to take a little more time to talk about. So we don't know b. I'm just going to leave it as b for now. My phase shift, well, we certainly didn't start our graph at 0. We started our graph at 0.3. So we shifted to the right 0.3. And then my vertical shift is usually supposed to start at 0. Well, my center is now at 50, so my entire graph must have shifted up 50 units. So that's plus 50. Now b, as I just mentioned before, is the number of cycles from 0 to 2 pi. And b can be found by using, we know period is 2 pi over b. If we do a little math, we know that b is equal to 2 pi over the period. So if b is equal to 2 pi over the period, and we already found out our period is 3, we know that b is going to be 2 pi over 3. So to complete our equation, we have y equals 10 cosine 2 pi over 3 x minus 0.3 plus 50. And we've now completed parts A and B. Now to complete parts C, D, and E, let's scroll back up for a second and take a look at those. C, D, and E is asking us, now that we have our equation and our graph, let's ask some questions to predict some distances or times when the weight is a certain amount above the floor. Now these three questions can be answered using your graphing calculator, and during class your teacher will go over how to do that. But for right now, what I'm going to do is just show you where they would be filled in to these equations. So if we have, and you can check out the answers right in your textbook. But so for part C, it says predict the distance from the floor when the stopwatch reads 17.2 seconds. Well, if we're looking from our graph, we got to think about what our x-axis is and what our y is. Our x-axis is our seconds. So anytime I talk about an x, I'm talking about seconds. Anytime I talk about y, I'm talking about how high above the ground is our spring. So if I want to predict the distance, I'm looking for the y value. And I want to predict the distance from the floor when the stopwatch reads 17.2 seconds. So I'm asking, what is y when x is 17.2? So to do this, we're simply going to plug in 17.2 in for x in our equation. So y stays as the variable. And we plug into this equation we just came up with 17.2 for x. Now this is the algebraic way to solve. You would then complete the math. You have to use your calculator to get that cosine function in there. Complete the math, come up with the answer, and that's that. And like I said, in class, you'll learn how to do this all on your calculator with no algebraic way to go about it. But your answer, after doing this, or if you're trying it on your own at home, your answer should come 43.31 about. And we're in centimeters, so you always want to make sure you label. Now part D is asking a similar question. Let's scroll back up and see what it's asking about. D says, what was the distance from the floor when you started the stopwatch? So again, if I'm asking for the distance, we're looking for our y value. And when I start the stopwatch, I want to say, okay, what was it at time 0? So what was it at time 0 is what we're looking for. So again, in for x, we're plugging a 0. So our equation here would look like y equals 10 cosine 2 pi over 3, replacing x with 0, then plus 50. Again, you can do the math algebraically, or if you can do it on your calculator, go ahead and do that right now at home. And when you get your answer, your y should come out to be about 58.09. And again, we're in centimeters, so let's make sure we label. Now lastly, we have part E. And part E is asking us, when was the first time the weight is 59 centimeters above the floor? So this time's a little bit different. I'm asking for time. So I'm asking for x, and I'm giving you a y. So the difference here is that I'm plugging 59 centimeters in for y, and I'm leaving my x now the open variable. Now again, you're going to do your math on your calculator most likely. When you figure out that math, you should come out for your answer to be x equal to about 0.08 seconds. So remember, on your calculator you're going to have lots of options, but it asks for the first time it reached 59 centimeters. So you want to make sure you're finding that first time, not some other time that it reached that point. And that was our conclusion of A through E on example 2 in your textbook.